Okay, we are here for video lab number 7 today. We're meeting today's team. Who are you?
Dean. Taro.
Terry.
Okay. And who from the audience can tell us what the lab is all about? What are we trying to do today?
Capillary action.
Capillary action. Here's your Doug question. What do we mean by capillary action? What is capillary action?
The rising into
Of what? You need one more part to it. The rising of what in a tube?
water.
More than water. Liquids. Okay? So you didn't get done. The rising of liquids in a tube. Now, today we're going to be using 2 different liquids. Let me ask you a question. Are you in a seat?
Mm-hmm.
Okay. What's one of the liquids that we're going to be using today? One of the liquids.
Dye.
What type of dye? What color?
Green.
Green. And what's the other liquid we're using?
Water.
Okay. And we're going to be applying these liquids to 2 different substances. What's one substance that we're going to be using today?
Chalk.
And what's the other substance that we're going to use?
Paper.
And what type of paper? Not just regular paper.
Chromatography.
Say it loud.
Chromatography paper.
Chromatography paper. Special paper that has been formulated to take dye and to break it down into its components, its parts, if it has components. Okay? All right, so who's got the paper and who's got the chalk?
I got the paper.
So that's what the paper looks like, and you got the chalk. Okay, now, what I want you to do, we need a pen or a pencil. Who's got a pen or a pencil? Okay, here we go. We need you to put an X at the top of that paper. And Terrell, we need you to etch in an X at the top of the chalk, because we need to always know which side was up so we can compare them. Okay? Thank you. All right, now, I need you to take the dye cup and put a dye dot 1/3 of the way up the paper. Little dab of do you. Okay? And now I need you to take the dye cup and put a dye ring about 1/3 of the way up the chalk. Okay, now we're going to do some measuring. We're going to measure the distance from the bottom of the substance to the top of the dye. What unit are we going to use to do this?
Millimeters.
Millimeters. How do you know what the millimeters are on the ruler? How could you tell which ones are the millimeters?
They're the very small units.
Small little lines, okay? And how many little units, how many millimeters make up a centimeter?
10.
10. So if you would take your ruler, measure from the bottom to the top of the die, and tell us how many millimeters do you start off with?
40.
40. And if you would write down next to starting millimeters, 40. And if you would do the same thing, Terrell, with your chalk and tell us what's your starting millimeters.
30.
And if you would write that down next to the starting millimeters. Okay? All right, now, let's take a look. Here's the die here, and here is the die there. And you know what? Nothing's happening. It's not moving. What's the problem? Why isn't it moving? What could this be? Is it busted? Or what?
You need water.
Ah, what?
You need water.
You need water. Okay, there has to be a driving force that makes the die move, and the driving force in this case is water. How much water should we use for the experiment?
About 50 milliliters.
Say it loud.
About 50 milliliters.
50 milliliters, or as we say in Beacon in the year 2001, 50. So I want you to go over there and put in 50 milliliters, and you go over there and put in 50 milliliters. And of course, 50 plus 50 is 100. All right, something like that. The face only a mother could love. You've seen this face on a milk container. Seen your face in the post office. Okay. Everybody set now? All right, now, did you want to check and make sure that the water level is less than the dye so we don't have a problem with that? Let me know if you're going to have a problem.
No.
Okay, all right. Now, what you have to do is figure out where you have to bend that so that you can get the paper into the water but not the dye. Remember this, Tanya, from yesterday?
And Allison.
And Allison, that is correct. They had a lot of trouble getting this part that he's doing right now. Took him 27 tries to do this. I had to go over and help them,
Yeah, you put it in the work.
and I did it too. Okay. All right, how long should we run this experiment for?
10 minutes.
10 minutes, okay? And on the count of 3, you guys are going to put the stuff into the water. Class, you're going to give them the count of 3. Give it to them.
1, 2, 3.
Okay, now what we're going to do is do a little observation and see what happens here. You want to know what happens to the dye when the water comes in contact with it, if it does. So far, nothing happening there. And it's hard for me to see in here because I've got a black and white viewfinder, so I'm not sure if anything's happening, so you're guys going to have to kind of like help me out on this. David, anything going on with yours yet? Looks like something at the very bottom might be going on. What's happening?
It's starting to get wet.
It's starting to get wet, okay? And is yours starting to get wet yet, Terrell?
No.
Not yet. Okay, now, it looks like there may be something happening to the color on yours, David. What's happening there?
It's starting to change colors.
Yeah, what color is coming out of that?
A little.
No?
Yellow.
A little yellow. Doesn't look like a little blue. It's a little yellow. And how about you, Terrell? We getting any color changes out of there yet?
Not really.
Not at this point. You can see that this is not a very fast process by which the water gets soaked up, although it seems like the paper has soaked it up much quicker than the chalk, because now the paper is definitely changing. Do you see the yellow bit better this time?
Mm-hmm.
Okay. You got to move your fingers out of the way, I can't say. Anything happening yet, Terrell?
Slightly.
Yeah, and what color is slightly coming out of that?
Yellow.
Doesn't look like that from here.
No. Looks blue.
Blue, okay. All right, so we have yellow coming out of the paper and blue coming out of the chalk. What's the relationship between those two colors that have to do with this dye? Yeah, blue plus yellow makes green. These are the components of green dye. Okay, now, it's going to take us a while to get through this. We have to run this for 10 minutes. And we're going to come back basically in 10 minutes to see what happens. But we can certainly see the dye moving on the paper now. It kind of looks like Batman. And let's see what's happening there. The dye is beginning to come out on that one now, Terrell?
Yes.
Okay. So what we'll do is we'll come back in 10 minutes, and we'll see what it looks like, and see you then. Okay, 10 minutes are up. Why don't we pull them out of the water and remeasure them this time? La 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 la. Okay, so we're remeasuring now. And David, what'd you come up with on your remeasurement?
85.
85, you put that down onto final millimeters. And Terrell, what'd you come up with?
60.
And if you would put that down next to the final millimeter, 60. And now, David, if you could just subtract the two numbers and tell us how many millimeters were covered.
45.
45, if you would put that down. And what's your number that you subtracted, Terrell?
30.
30, if you could put that down next to millimeters covered. And then turn the paper around so we can see what it is that you wrote. Turn it around this way. You doing it again?
Oh, this way.
That's the way. Okay, now, in the chromatography paper over 10 minutes, the dye was able to move 45 millimeters, and the same amount of time in the chalk, it was able to move 30 millimeters. So one of the differences is how fast it could move through the different substance. Which substance lets it move quicker? The paper or the chalk? The paper, which makes sense to us because that's the job of that paper. But that's not the only difference. All right, what I want you guys to do now is to take the two items, the chalk and the paper, put them right next to each other on the table with the X's facing you. Right next to each other. Okay, and what I'm going to do is I'm going to put the camera on macro, which is enabling me to get right down on it, and we'll actually take a look at the colors. I have a still picture right now in the viewfinder, and it's kind of different, the colors, in terms of the chalk and the paper. What's different about the colors that are in the chalk and the paper? Who can tell me? Say it loud.
On the paper, the yellow's on the bottom and the blue's on the top. And on the chalk, the yellow's on the top and the blue's on the bottom.
Yes, so the colors have come out in an opposite order, and that's what we're looking at right now through the viewfinder. So let's stop that and come back to the regular class. Okay, so my question to you is this. Why did the colors come out in opposite orders? What caused that to take place? Think about it. The chalk and the paper had the colors go through at different rates. How come? Yes?
Because they're made up of different materials.
Yes, there are different substances. The molecules and atoms that make up chalk are different than the ones that make up paper, and they allow colors to be absorbed at different rates. Very good. Next question to you. Why did the dye move at all? Why didn't it just stay there and not go anywhere?
Because of moisture.
Because of what?
Moisture.
Not moisture.
Capillary action?
Yes, because of capillary action. It was the rising of the liquid level in a tube. So what shape is the chalk?
Tubular.
It's a tube. It's a cylinder, okay? But what does the paper have to do with tubes? Paper doesn't look like a tube.
It's made out of
Say it loud.
It's made out of tubes.
Yeah, but the only way we can actually see that is if we use a what? So, Erica, I want you to go over to that microscope right now, take a look into it, and tell us, there's a piece of chromatography paper that's there, and tell us what you see in the microscope.
Tubes.
Tubes, that is correct. It is totally tubular. All right, my next question to you, and the last question of the day. You need to visualize. You have to make believe you're not here. Some of you are not here. But in any case, now you have a chance to actually leave through your mind. Make believe you're in your kitchen right now. You all got that? Someone's in the kitchen with Dinah. Someone's in the kitchen, I know. Or we can do it as a rap. Okay. So, you're in your kitchen right now. You're supposed to help me out there, you know. I know, you wanted to help me out which way did I come in. In any case, you're in the kitchen right now, you're eating a sandwich. You're all visualizing this, you're eating a sandwich. You couldn't finish the sandwich. You want to put part of that sandwich away so it'll be fresh for later. Think about what you could use in the kitchen that has a blue part and a yellow part to make green that will keep the sandwich fresh.
Ziploc bag?
Yes, did you ever see any of these Ziploc bags that have a blue and a yellow section? How many of you have ever seen that? Does anybody have one of these Ziplocs? Oh, you guys do. Okay, here, let's see this. Open it up. This looks like a commercial for safe sex here. Hector, when you're one hector of a guy. Okay, so let's see the different sections that we have here. That's the yellow section. Turn the other way around. And the blue section, right? Now put them together and make for us green so we know that it's sealed. Make green for us, please. Okay, and when it turns green, what does it mean?
Close.
It means it's closed. Okay, so knowing the concept of blue and yellow makes green helps you keep your sandwich clean. Something like that. A poet and don't know it. And this ends video lab number 7. Let's do it again. And this ends video lab number 7. Oh, much better.